Hey, awesome. We're live.
Hello.
Cool. Hey, everyone. Thank you very much for taking some time with us today on the live stream. Awesome. So we have here today with us Eric Andrews, lead developer at Streamr, and also Juuso Takalainen, who is Ethereum dev at Streamr. So maybe to begin, we're going to have some people going to jump up later on in the live stream, but we can maybe begin with a very fast introduction about yourself, maybe Eric or Juuso, maybe who would like to begin?
Do you want to begin, Juuso?
Sure. Yeah. Okay. So Ethereum developer is pretty much my title, or what do you want to call it? Job. So I've been doing Ethereum stuff in the Streamr project since the late 2016. So that's already quite a while, good 5 years or so. And yeah, so I mostly responsible for the implementation of the smart contracts and everything related to the blockchain side.
Awesome, cool. So thank you very much. Eric?
Hello, Eric Andrews. I've been with Streamr for a long time as well, since beginning of 2016, and been working on Streamr in all of its carnations basically since then. And right now I'm working mostly on the network side of things. So if you're a developer, if you're using the Streamr client, I've worked on that, and the network, that kind of package that the client uses underneath that. And then if you're running a miner, then you'll be familiar with the Streamr broker package. So those are the things I've been working on recently, but dabbled in all sorts of things during Streamr's lifetime.
I guess there was a long journey for you as well. Awesome.
Yes.
So we have today a couple of questions from the community. We will try to answer them as best as possible. Please forgive myself. I don't have that technical background neither, so if there's anything, feel free to just correct me, Juuso or Eric, and we can jump on with the first questions. So the first one that we have here is, when Tatum is rolled out and there is more traffic on the network and more data packed have to be distributed and validated, can we already estimate what the minimum hardware requirements are to be able to operate for a broker node?
Yeah, I can take that. So it's still a bit like we can't say for sure about that, but there's like certain elements of that I can discuss. It will depend on which stream you're brokering, of course, and how much data is going to be involved in that particular stream. What is the data rate of clients publishing messages to that? It will definitely be like the main constraint will be like the bandwidth. Of course, that's the main thing going into the Streamr network. But additionally, there is like memory and CPU requirements. Just because the WebRTC library itself is a bit taxing on the memory side, and there are some like checksums that in the protocol level need to be calculated. But in our current model, sort of the most of the validation work is done at the ends of the system. So you'll have the client publishing the message, which does the signature, signing the message and encrypting the message. And then at the other side, there's a subscriber that decrypts the message and checks the signature. So in the current sort of incarnation of the system, sort of the heavy lifting with regards to CPU and memory is at the edges of the system. So sort of the light nodes, we call them, sort of the users of the network, whereas the broker nodes, the miners in the middle, are more concerned with bandwidth. So that's the current kind of way it is. There's definitely potentially going to be more validation added into the kind of center of the network as well. So there you could expect to see a bit more like potentially CPU and memory requirements, especially in certain conditions. But mostly bandwidth. But yeah, no like concrete numbers yet at this point.
Of course. Yeah, and I think for Tatum, it's going to be is for quite soon, but after in maybe 5 or 10 years from here, of course, a lot of people would love to know much more about the numbers. If it will cost much more, those kind of things. But I think it's quite difficult to know this today, or can we estimate something?
And again, if there's like, if you're running like the, let's say the miner, there's going to be different kind of options available with data rates. So like what kind of a stream are we talking about, right? Is it like 50 kilobytes a second, or is it something larger or smaller? Whatever it is, like, right, that's going to affect it.
I agree. Okay, awesome. Thank you. So we have a second question here. Is it possible to implement some kind of auto start function into the node software? We have some people who have sometimes some nodes who had stopped since the beginning now. So we launched mainnets a couple months ago now already. So we're having a lot of people running some nodes. And of course, sometimes when you go to sleep and you wake up and you saw that you didn't receive all your rewards, sometimes it could be a little bit annoying. But is there maybe something to implement maybe in the future, or how do you guys see this?
Yeah, it's been brought up in our dev meetings occasionally, this kind of need. Currently, you can sort of get this functionality by doing it yourself, in the sense. So there's different kind of like service daemons that make sure that the service is running, that are kind of third-party options. One that's popular if you're using like the node package directly, so not the Docker solution, but you've actually installed it through npm, is PM2. So the library called PM2, you can install that and it'll do the monitoring sort of for you, and it will auto restart the service. And then there's also like, you can set up this systemd file. I think like Karre, one of our developers here, posted an example in the Discord channel. So our view currently would be that we'd rather fix the bugs that cause the issues and not have to build this functionality in. But if you want this functionality, the view would be that you'd set up a third-party solution to that. But we'll have to see how it views.
Yeah, I mean, it's like almost any web service. It's better that it fails fast and then it restarts. So I guess with systemd is a standard tool for if you're running it on a Linux server. You set it up to restart when it crashes, and then you should be fine. In that sense, it's auto starting.
In one of the older versions of the broker, there's this issue where it will freeze, but that's fixed in the newer ones. So that wasn't a particular situation I want to just bring up, because you could basically some systems allow you to kind of look at the logs being generated, and if you can make like rules that if there's no logs being seen for, let's say, 15 minutes or something, it'll kind of restart the service, and those kind of rules. But yeah, no official plans yet to kind of support that. We're kind of focusing on fixing the issues and then looking at that maybe.
Seems very fair. I think it's more important to be able to fix everything. Tatum is also approaching, so I think it's important for you guys to make sure that everything rolls perfect. Okay, so we have here, it's a question as well mentioned on Discord. It's maybe not 100% technical, but I think it's always great to have also your thoughts on this. But there's a lot of Web3 competitors today in the data marketplace. How can Streamr stand out among the competition, and what is unique about us?
Yeah, I'd say.
Yeah.
What do you want to use? Start.
There's a small delay, so.
Yeah, sure. I mean, okay, fair enough. Yeah, I guess the typical Streamr pitch. Streamr is the real-time data stream protocol, meaning that the real-time data streams are not so much what is in the data stream. We deliver them usually packaged in JSON messages, but what differentiates real-time data from any database data is that it's valuable when it is new, when it is delivered and consumed fresh, meaning that the data itself is valuable in a different way. I mean, let's say typical large data sets that would be bought and sold in these data marketplaces. They could be anything that you would collect and then data mine and analyze and whatnot. But then the sort of real-time data, we can let's take an example. Let's say location data of car. We usually like this self-driving cars example. So the location of the car is a data. You can get the location from your GPS, I don't know, once a second or once every 10 seconds or whatnot. Push it into a data stream, and that data stream can be interesting later, but yes, for many applications you will want to have that location immediately. So you could do things like aggregate that data or those data into some sort of maps of congestion and whatnot. So then when the value of the data is in the freshness and the low latency from the data producer to the data consumer, this is where a real-time data streaming network is different from any data marketplace. I mean, if Streamr marketplace, which is of course only one application on the Streamr network, but the monetization of data streams is different from monetization of data sets for machine learning or whatnot. In that it has to be delivered fast. And this is in some sense, I think, the differentiating factor. So Streamr aims to not only deliver the data and take care of the incentivization of data brokering, but and then perhaps the monetization as well, but also to do that with low latencies and so that you can sort of squeeze the most value out of your data streams.
Yeah, 100% agree. Eric, would you like to add something on top of that?
Yeah, like Juuso said, the real-time use case. So there's data points whose value diminish over time, and being one of the first receiving that data point, being the first to receive some news is usually beneficial in many use cases. So that's the kind of use case Streamr network is really great at. And then it's this kind of data, but also like someone wanting to use the pub sub functionality of the Streamr network to build like a decentralized application. So for some Web3 project, if they want to be truly decentralized, they want to build on top of, like Web3 technology as well. So you can also use this technology to build like a multi-service system where you have services communicating messages to other services running potentially different machines and those sorts of systems. Question was about Web3 competitors, but of course, just highlighting the difference with Web2 is the really decentralized manner of the system. So really there is no central party there controlling what goes and what doesn't.
It's very broad.
Yeah, and I mean, I think here it's fun to sort of reminisce the Streamr's background. So where Streamr came from. Originally, Streamr was a tool for creating these automatic trading algorithms. So you would create your algorithm, and then it would be sitting in the trade or next to the trading room or whatever in a good spot to be able to execute the trades fast. But then, yes, it implemented data ingestion and simple transforms.
Can you use excuse me? Can you just come 5 seconds or 10 seconds before? We just had like a very small lag, I think.
Oh yeah, for sure. Yeah, sorry about the internet.
Course.
Yeah, there's something funny about it today. But yeah, so so Streamr's background as the algorithmic trading platform, and the basically the way it would work is that it's a simple data transfer, first data ingestion, simple transform pipeline, and output would be, for instance, buy and sell orders or whatnot. And of course, this is prime use case for low latency data. So you would input things like sentiments or whatever you imagine will affect the prices of the tradables, and then yeah, weather data if you think that matters, or tweets or whatnot. And that is really where Streamr is coming from, and yes, that's where I see there's a real-time data pedigree in that sense in the whole Streamr project.
It's awesome. Yeah, it's always great to be able to come back 5 years ago and just like, oh, okay, this was the idea of Streamr Network. Of course, there's so much happening, not only with one ID, but there's a lot of different points. So I think it's always fresh to be able to come back, and I think what was really the goal here. And the goal is almost there. So Tatum is the last milestone. Of course, it's not the end of the work, but it's the last big one as well. So yeah, awesome. Maybe I can go with the next question if Eric, you would like, if you didn't have anything else on your side.
Yeah.
Awesome. So what are what are these 3 sockets or plugins at Streamr Broker in its stage? When and how they become useful?
Yeah, so they're mainly meant for builders who want to subscribe to data or then publish data. So if you want to kind of interact with the Streamr network, there's 2 main ways. One is using the Streamr client package directly, and that's sort of the preferred way, I would say, if you're building your application or your integration script or your analytics script in JavaScript, either in Node.js or the browser. But then if you're building your app or integration in another technology, Java, Rust, Python, whatever, then the broker plugins are the way to interact with the Streamr network. So the idea is that you run a broker and you enable, let's say, the HTTP plugin, and that will open up the HTTP port on that broker instance. So you have that thing running there, and then you have your app running. Let's say your app is something that's, let's say it's publishing weather data every 5 minutes or something like that. So it'll use that HTTP port that we opened with the HTTP port to communicate that every 5 minutes there. So
breathe, Juuso. Take some water.
Yeah. So that's the idea there. So they have their use in a builder situation.
Okay, awesome.
Yeah.
Are you okay, Juuso?
Yeah, it's I drink water, just water.
Happens to everyone.
Yeah.
Had to happen in a life, of course.
Yes.
Okay, cool. So the next question I think is also for you. So are you ready, or do you need a couple seconds?
Yeah.
Okay, awesome.
Right.
So this is a question about Ethereum 2.0. So of course, this is something that we've been waiting for, we can say now, a couple of years, because there was a lot of big important changes, of course, at Ethereum. But what are your thoughts on this, and what can we maybe expect as well on 2.0 from Ethereum?
Yeah, I mean, Ethereum 2.0, I guess you could say it's the sort of enterprise grade implementation of this original world computer idea. So the original EVM, of course, has become something of a standard, you could say, interface interface between applications and the underlying consensus mechanism. But yeah, I mean, so what Ethereum 2.0 promises to deliver is cheap transactions. Of course, we already have cheap transactions in all these different chains that have an underlying mechanism that is different. Like if you go to Avalanche, you get fast and cheap transactions in their different type of consensus mechanism. I think, yeah, Ethereum 2.0 doesn't aim to be very radical, of course, since Ethereum is a huge ecosystem and not anymore maybe the sort of playground of trying out new things so much. But yeah, so it's more like an enterprise grade implementation of this Ethereum idea. And yeah, so of course, if it like it's already running, there's the beacon change running and all that. But once we get also smart contracts there, which I suppose is very much happening all the time. But yeah, soon that we get these smart contracts there as well, that we would get cheap transactions on the base layer, such that we wouldn't need to go to the cheaper chains for the sake of the transaction prices. And because I mean the different chains, the problem is always bridging between the chains. You can you can build all these bridges, and you can even make them somewhat trustless, somewhat decentralized. But there's always quite a lot of cost. Yeah, it's simply very cumbersome to interact from one chain to another. So have the cheap transactions on the base layer, and then the shard communication. Of course, if there's going to be like these different shards, I'm imagining that will also be a lot smoother than any ad hoc bridging or even. Yeah. So I guess that's it. Cheap transactions. Other than that, yeah, it's a good thing that Ethereum will be hopefully able to sort of claw back the the sort of leading position in terms of in terms of where all this DeFi and whatever the next big thing will be, where it is happening. I mean, right now it has gone to the cheaper chains, very much to Polygon and others, but perhaps Ethereum 2.0 will then be again the sort of center or nexus of all the DeFi activity. We'll see.
Yeah, I agree. I think it's going to be a very exciting moment to be able to participate in this ecosystem as well. And related to Streamr, I think as well we can maybe see this as something as well good, because today we need that kind of trust that with other blockchains as well. For example, today it's Polygon. This is the sidechain that we are using to be able to stake the data tokens on the nodes today at Streamr. But when the transactions will be less than today, at that moment, it's going to be maybe as well better for Streamr to be able to stake data tokens with native tokens directly on nodes as well. Today it's quite expensive, of course, but maybe in 2.0 that will be as well possible. These kind of things, I think, it will be great, not only for Streamr, but the whole ecosystem for it.
Yeah, there's nothing preventing really implementations of staking in native tokens now, or in like the mainnet data tokens. Yeah, I mean the value of the token. There's some spread in the value of a token in different chains, perhaps, but typically, I'm guessing the value of a token isn't so much affected by in which chain it is. But of course, everything else, like we are building this whole tokenomics system and incentivization of the brokers in a smart contract way, and all that will be so much more ergonomic when we can all be in the sort of same global address space in some sense. So right now, the sort of main idea or main paradigm of building these dApps is going multi-chain, meaning having the app available in these different chains just to serve all the potential customers. And I don't see multi-chain really necessarily going anywhere. But then if Ethereum 2.0 would again regain the sort of central position, then at least that will make a lot of things very straightforward again. Yeah.
Exactly. Any thoughts, Eric?
Basically, same stuff. We're pretty much a user of the blockchain in many ways. So how we handle identity, permissions, and then value transfers in our system all relies on smart contracts and transactions, and having those cheap would be great. And of course, as you guys both alluded to, the whole bridging functionality, not only does it bring like conceptual overhead, but also practical overhead and a lot of that. So it would be great to get rid of it. And personally, I'm rooting for Ethereum 2.0, so waiting for the best on that. I've always kind of liked the way they work, the Ethereum Foundation.
Yeah, so you've been waiting years as well.
Yeah.
Okay, awesome. So we have a next question here. So we know about the broker nodes, but can you guys explain what a Streamr Lite client is?
Yeah, that was the thing. Basically, we used terminology like a light node to refer to the concept where whenever you interact with the Streamr network, be it the browser, be it a Node.js script somewhere publishing data, subscribing data, being anything, or being like the broker, running a broker node and mining your node in the network. So the idea is that if you're just there to subscribe or publish data, you're also participating in the propagation of messages in that stream topology, we call it. So this mesh of nodes covering a stream and the messages of that stream. So basically, whenever you open the browser, you interact with the Streamr network, you're actually participating also in message propagation, and thereby also providing like a scalability and bandwidth to the network, but also security to the network. And there's also there's exactly know what light client refers to, but I'm assuming light node, but there's also like a light client functionality, which is a bit like it's a release thing, but it's a bit like still experimental, where you can have you can run a Streamr client and have it kind of not participate in the network, but only be there to publish or subscribe to data.
Will we be able to stake? This is always a big question, but today in light nodes we can't stake any data tokens, but later when we will have maybe just a Mac or something, we will have some light nodes running when we're active. Do we need to stake, or how does that work?
Yeah, that's a good question. I think there's those kind of plans. It's mostly for the minor nodes to stake, because they are basically promising to provide something to the network. So if I'm getting paid to do something, I'm staking something there just in case I don't do what I promised to do, sort of as an insurance of some sorts. I think there could be useful properties of having light nodes also stake. Of course, it would increase the barrier to entry, which is not necessarily a nice thing, because you would have to hold data to enter. But I guess you could kind of provide some sort of guarantees with respect to maybe some, cyber attack situations where you're creating loads of accounts and trying to claim that, hey, these friends here, that these are actual nodes on the network. I don't know, there's potential value in that idea, I think, in that kind of sphere, but this is now in a very hand wavy territory, so I can say for sure.
No, I mean, as Eric pointed out, it's the idea of staking is basically that whoever puts down stake, they have something to lose as well. So that will then hopefully sort of make it more profitable to play by the rules and so on. But yeah, so in that sense, it's the brokers who stake in order to receive rewards. So the whole point of staking from the broker's point of view is, of course, that staking enables them to also then benefit, in terms of tokens as well. So that's how this, in some sense, becomes an investment into participating in this product, and then the staking basically happens through these bounty smart contracts. Bounty is called that because when somebody wants a stream to be served by these brokers who expect who expect them to get paid and who want to do this in order to earn the rewards, then they put down a bounty in the data token, and then this bounty is paid out to all of the brokers who join it. So all of the brokers who sign up for the bounty, and when you sign up for the bounty, you basically put stake, and so that's the whole tokenomics part. And there's going to be that part, and then other data token holders that don't want to run their own broker, but they want to still stake on these brokers, meaning they want to spend or invest their data tokens and provide basically provide the capital to the brokers to then stake into the bounties. They can in the Tatum implementation then they can basically lend out capital to the brokers, who then use that capital to perform useful work. So we have brokers performing work, and then these delegators, we call them. So basically investors providing capital, and the delegators, they get paid when the broker gets paid by the bounty. So and then broker will sort of pay back the investment or pay dividends on the investment. So there's all that. So basically, if you believe in a broker, you can provide them the capital to join more bounties, and then the broker that way can sort of utilize their bandwidth and other resources maximally. So that's the big picture of the tokenomics that is coming up. So the stake is, on the one hand, from the system's perspective, or from the stream sponsor perspective, the stake is an extra guarantee that the brokers will actually perform useful work. And then from the broker's perspective, it is the capital that they employ in order to earn yield on that capital.
Yeah, awesome.
So,
this is why a lot of people can't wait for Tatum.
Yeah. I mean, it definitely provides a framework for the tokenomics of these data streams. So you could imagine it's fun to compare the Streamr network to BitTorrent. Of course, we expect this to be a bit more well, more like a business-oriented version, but the BitTorrent is different, or whatever peer-to-peer networks, in that they aim to deliver basically a large data package, a file or whatever, from one place to another, and in order to do that as fast as possible for a large file, you would try to sort of saturate all of the bandwidth that you can. So in the end, you might be able to transfer that file with very large bandwidth, so that in the end, the whole file will be there very fast. But of course, it is different from the idea. I mean, still the latency might be huge. I think, yeah, a common comparison is like, what is the highest bandwidth way of moving files from one place to another? It may be putting them into some kind of storage medium and then, hopping into a car or an airplane and moving physically to different place and plugging it in. But of course, the latency is huge, and that's kind of the trade-offs. And in that sort of scale or axis, then Streamr wants to be the opposite sort of. Streamr doesn't need to saturate your whole bandwidth, because Streamr just wants to get the messages from one place to another fast. So we are kind of, inverse or converse of BitTorrent in that sense. So and yes, in the answer notes, like, what is Streamr Light Client? Like, not participating in the network is a little bit like leeching in BitTorrent terminology. So you would be just hanging around, but not performing work. Like, not
exactly.
Passing on. Yeah. And then the question is, would that be useful? Or, well, the question is, of course, what is the bottleneck resource? So if your bottleneck resource is CPU or the electricity or whatever, then perhaps running that light client might not be any lighter than running a normal client. So probably it is not going to save you anything. So it might be slightly lighter on the bandwidth, but you're probably not going to win by using this light client feature. It's for maybe scenarios where, I don't know, like NATs or something like that. There's some reason why you cannot connect anywhere.
No, yeah, and what's most important, I think, is really the fact that it makes the network much more decentralized. This is something where it's very important also for the security at the end of the day. And I think for everyone, it's very important to be able to use a decentralized network is something very complicated, a real decentralized network. So I think these kind of light clients and nodes is something very important as well in the long run. I think BitTorrent is a very good example as well. People participate. They don't have to, but they can. But this is what makes peer-to-peer very strong today. We saw this in the last more than 20 years. So I think, it's a very good example.
It's a useful property in the sense that any node in the network can act as a server, so to say. So of course we work on a peer-to-peer network, but you can view these individual interactions as server client. Any node can take up on the role of a server, act as a server in a sense in the system. And there are potential situations like adversarial censorship happening or downtime situations where this can be really nice and beneficial.
I agree. Yeah, exactly. Okay, awesome. So we can stay a little bit in the light clients questions. I have one more here. So you can use a light client to subscribe to streams, but can you use it to publish data points to a new stream? And also, can you use it to publish a brand new stream?
That's all possible currently. So you can check out like the network docs see how it's done technically. So yeah, you create a stream. For that, creating the stream, you're going to need some of this. What's the Polygon token again called? I forgot what it Matic. Yeah, Matic. You're going to need some of that, and you'll create a stream. So entry gets written into the smart contract there, and then you can start publishing data, and it'll be a private stream by default, so the data will be encrypted, and then you will write to the smart contract again, either to give out permissions to other users or Ethereum identities rather, or alternatively you make it a public stream, so anyone can subscribe to the stream, and then the data will not be encrypted. It will still be signed.
Yeah, I think it's good to sort of keep the discussion going. What is the thing that people, what kind of lightness they are looking for?
Mm-hmm.
Because of course, once right now we are using TypeScript for the implementation in order to iterate quickly, and yeah, in future we might be able to sort of, once the sort of implementation settles into more stable and fixed point, then of course we can try to implement it with more lower level languages and frameworks like Rust or whatnot, so that might be more efficient, run more efficiently. Of course, there's always the question of these WebRTC libraries, how they are available, and so on and so forth.
Yeah.
So really the question is what kind of lightness people would be after. Should it be light on the CPU, or light on the memory, or light on the, we all know that the running Ethereum node is not very light on your disk. So yeah, I mean, Streamr node is not going to require 1 terabyte SSDs, but still, what sort of, where is it that performance matters most to people, and this could be interesting to hear, because there's no point in trying to find the lightest possible client right now. Maybe, I mean, you might, it's best now to just run the standard thing. There won't be anything that is super light by the virtue of adding a switch into the command line or whatnot. So it will be essentially the same thing anyway.
Yeah, it's kind of interesting. Is it like lightness of the bandwidth requirements? Because that will, obviously the technology choice of the library won't matter in that point. But if it's like CPU and memory and squeezing out everything out of that, then it's true that implementing it with something a bit more low level, with a language with like maybe not automatic memory management or that sort of thing, that it would probably be faster. But yeah, the good thing about TypeScript, of course, it's quick to write and that sort of thing, and it's easy to, relatively easy to verify correctness of things. So
yeah, and I mean, we might be able to find a more efficient library even if we use TypeScript.
And you can also what we can do is
the protocol.
Yeah, we can also write parts of things that are especially, let's say, core algorithms can be written in a low-level language, and then they can be kind of interacted with a higher-level language. So you can kind of do that kind of tricks as well.
Yeah, awesome. Can't wait to see all of this as well. But these are of course things to think a lot about. Some brainstorming is needed sometimes. So. But very nice thoughts like that. We have here a question as well about your views about what are the developers' views on combining Streamr with other storage solutions, centralized or decentralized?
Yeah, suppose what's meant with this is storing the contents of the streams, so the messages themselves. So currently we do provide this functionality, but it's mostly like something that's provided by us currently. So we run this service, but it is implemented in a way where anyone could become a storage provider. So actually, the idea is that when you create a stream and you want that stream to get stored, you'll assign that stream to a storage node. So we call these special node storage nodes. So they join the stream topology just as any other node, with the exception that whenever they see a message, they'll store that somewhere. So we're running one of these services currently, and it's a centralized version of this thing. People can also run their own storages as well, and you can take any stream and assign it to a storage node basically and have it store that. With regards to like other decentralized solutions, I find that an interesting topic, because certainly there's been many projects out there that want to figure out how do we store things decentralized, especially in a way that we can have some kind of proofs that this thing is actually getting stored. Not that it's just being claimed that it's being stored, but actually when I go and it's time to fetch that data, it's not going to be like a, like a bank run. There's no data there, but the data is actually available there. So it's, I do see there could be.
Yeah, this is. I can definitely see this be like a next milestone thing. Like after datum, like if there is clear demand on the one hand, creating storage nodes into the or incentivizing storage nodes in the Streamr network, meaning creating the similar tokenomics brokers have, that they join basically a brokering bounty, but storage nodes would join a storage node bounty and then start earning, and then whoever wants their stuff stored would pay just like you would pay Amazon or Azure or what, or Google to store your data. So that could be completely decentralized, and or then on the other hand, if we could have a storage node that is somehow run on what that platform would be, and then storing that stream contents into some storage or whatever file there is, and that way the storage itself. It's kind of still hard to see how to do that completely. In like with just smart contracts. That would be super interesting. But yeah, so definitely there's lots of angles there.
And we've actually, in talking about it in the code base, it's actually, there's a specific like interface. If you're a Java developer, interface you can implement, and you could like connect this with like, I don't know, IPFS or something like that, and have it store data there. So it's not like it's that out of the blue idea in any way, actually. There's certain operations that then just need to be supported. So storing messages, but also retrieving them like by timestamp is a kind of feature. It's kind of like a time series store is the model there. So anything that conforms to that is queryable in like this time. Like you can do these time frame queries, like give me all the data between these 2 dates. It'll work kind of well with Streamr.
Oh, at what project do you mean?
Sorry?
Did you mention a project there, or
I was just name drop like IPFS. That could
be.
Like, you could try connecting it with that. I don't exactly know what query capabilities they have, but I could see that working.
I agree. I think that this is really awesome to talk about. I think it's very important as well for a lot of companies also later on to be able to understand how they're going to manage this. I think that we have a lot of very old projects like storage. We have Filecoin as well, all these kind of people who are trying to push this kind of, as you perfectly mentioned, Eric, this decentralized storage. It's so important. It's still not 100% decentralized. And I think there's a lot of thoughts, a lot of brainstorming to do behind this, but we can always also use some insights from our community. I see that there's a couple of great people as well in the chat who are also trying to develop a couple of things on top of Streamr. And I think getting some ideas as well from the community is also very interesting. But I think
Just like centralized world, like the storage solutions, there's really no one size fits all. So there's relational databases, there's time series databases, there's graph databases, then there's just plain old file system and everything in between. So many ways.
Yeah, but definitely Streamr is more on the data series. I mean, right now we have support for that, and yes, where Streamr was coming from again, like the algorithmic trading. So so you would have the streams that are basically the incoming data that is ingested and then transformed, and that would also be automatically stored, so that later you can create new algorithms and see how they would have performed on the past data. That sort of thing is called backtesting, that you take old data, run your algorithms on old data, and of course then handsomely overfit it to old data and lose everything. But still the idea that using the old real
train
data,
the model with that, and then you can react to real time data.
Or just test your trading algorithm ideas on the old data. But of course we now that we've been sort of decentralizing this piecemeal the Web 2.0 Streamr, which was this kind of web service. So so we've taken now the network first. So the other pieces, which are the automations and the storage and all those, they may then be part of later milestones, depending on the demand.
Yeah, awesome. Really nice talks here. I like that. It's always great to be able to see the future in front of us. So we have very last question here. So we answered all the questions from the community. So thank you very much for that. Maybe it will be great to give us a little bit of more like a view about what you guys are working at this moment, and up to maybe Tatum, for example, if that's fine with you guys.
Yeah, I can start. I can describe the network. There's two broad things happening on the network development currently. So our team is split into two task force. The first one is we've been having this component in the network called the tracker, which is kind of a semi-centralized solution there, which has aided in a few things. Firstly, the ability of nodes to connect to each other. So there's this WebRTC protocol requires this relay node that does this. It's acted there. And it's also being responsible for forming sort of the random graph, which is the topology that's currently used for the streams. So it's kind of said, it builds this graph and it says you connect to this guy and you connect to that guy and so forth and so forth. And then there's been sort of the value of also being able to gather information, because it's this centralized component. It's been able to view kind of the entirety and bring us understanding about that. But when we were running this Brubeck testnets, we actually discovered that the tracker has like a scaling limit, which it did scale very well to a large number, but after that it kind of couldn't handle it anymore. So kind of combining those two challenges, so the centralized component, not so nice to have, and also the scaling limit, there's this thing that part of the network team is working on, which is decentralizing the thing, so having a trackerless approach. We call it the trackerless approach, and in that approach, we don't need this centralized tracker anymore. We replace that with like a distributed hash table. We have this multi-layer approach there, where nodes can then use the DHT to discover who they should be connected to, and those sorts of things. So that's the nice thing about that, like one less centralized concept or thing in the system, and then the ability to scale. So there's not this central thing that keeps computing this graph all the time. It just grows and grows, but it happens like it's like a distributed calculation there in that sense. So that's one part is the trackerless thing. And then the other thing the rest of the team is working on is this free rider detection. And that links to the tokenomics that Juuso is more involved in. But the free rider detection is detecting nodes who are minor nodes, so they've agreed to certain terms and they're getting paid to do this work, to propagate these messages, and we're trying to build a system that detects when someone isn't doing this. So when there's nodes there that aren't actually contributing bandwidth to the stream, but are actually slacking off or something like that. So we're building systems where nodes agree upon what they have sent to each other, and then we can do like these inspections of nodes, like, hey, we have a suspect of some node perhaps not being up to date or being able to propagate messages, either due to it can be like ill-willed, they're just kind of change the code somehow not to propagate messages, but it also could be just that they don't have enough bandwidth, so they've taken up too much work in what they can handle. So detecting those and then providing this information to the higher level, then I guess what Juuso is more working on, so the tokenomics layer.
Awesome, thanks for that update. I know that you already talked about this, Juuso, but would you like to add maybe something above it as well from the tokenomics, or?
Yeah, I mean, details of the tokenomics are probably still a little bit in the flux, but the basic idea is, of course, that brokers can sort of they can trustless. They can trust that they get paid when they do the work, that the tokens are available at all in all circumstances, that they get notified if the tokens are about to run out, and so on and so forth. The sort of optimization of suppose there will be several bounties to choose from for a broker, like optimizing which bounties to join, with how to sort of distribute the available capital for staking, and so on and so forth. That will come after the system is set up and running. I mean, ideally, running a broker will be a little bit like some nice hash that you just leave it running and it will join bounties that are available, and so on and so forth. But how exactly that will happen is still sort of in the works. We are working on the smart contracts still, and it will be some time before automatic joining becomes part of the client. But in the meanwhile, we'll probably have some form of user interface. But I mean, how it will look and how it will be used is still in the works.
Great. Thank you very much for this. Cool. I just wanted to mention for the people, if you still have any questions, people who are actually watching this live stream, feel free as well, because of course this is a dev MEA, so we're not able to answer all the questions that were mentioned, maybe as well in the chats. So feel free to join our Discord. We're very active as well there, so you can also talk with other people. If you would like to talk about the price, we are not going to talk about the price, but there are some channels for this where you can find other people as well. So feel free to join. And yeah, I think we're done for today. So really cool. Thank you very much for answering all the questions of the community as well, and getting here for almost an hour with us on live stream on YouTube. So it was really cool. Thank you, Eric and Juuso, for today. And I wish you a very good evening where you're at, and hopefully to see you very soon.
Yeah, All right, great stuff.
Same. Stay tuned.
Cheers.
Bye bye. Bye everyone. Thank you very much.